Every once in a while, humanity hits a turning point, a moment when the ideas we used to call science fiction suddenly step into the real world and demand our attention. Right now, we are standing at the edge of a shift that will redefine how we move, work, communicate, and survive. Today's breakthroughs are not just upgrades, they are world-changing inventions that will reshape everything we thought we knew about the future. If you are ready to see the tech that is rewriting the rules of what is possible, then settle in, because what comes next is nothing short of mind-bending. Let's get started. Boston Dynamics Atlas is one of the world's most dynamic bipedal robots, engineered to demonstrate advanced locomotion, balance, and whole-body manipulation with grace and strength that rivals human movement. Standing about 6 feet 2 inches tall and weighing around 198 pounds, it blends cutting-edge hardware and intelligent control systems to walk, balance, and interact with complex environments in ways few robots ever have. Atlas uses 56 degrees of freedom with fully rotational joints and an advanced electric powertrain that supplies precise and responsive motion across its limbs. The robot's onboard perception suite includes LiDAR, stereo vision, and tactile sensing in the hands, all feeding real-time data into its control system so it can adapt to the terrain, maintain stability, and navigate obstacles while moving. Its balance and agility systems let Atlas perform fluid walking, dynamic balancing, and recovery from disturbances that would topple less advanced machines. During demonstrations, it has shown the ability to regain upright posture after slips, traverse uneven surfaces, and complete coordinated movement sequences that require precise timing and strength. Atlas's strength extends to manipulation as well, allowing it to grasp, lift, and handle objects with fine motor control using its advanced hands while maintaining balance. It can lift significant loads instantly and sustain a portion of that weight during complex tasks, enabling practical material handling in industrial contexts. FlexiVol is a groundbreaking three-dimensional volumetric display developed by researchers at the Public University of Navarra that projects true 3D graphics into mid-air you can see from any angle without glasses or headsets and interact with directly using natural hand motions. Unlike conventional volumetric displays that use rigid oscillating surfaces, FlexiVol replaces that component with flexible elastic diffuser strips that let users reach into the display volume and grasp, push, pull, rotate, or slide virtual objects as if they were tangible, making interaction feel intuitive and close to how we already manipulate touchscreens and physical objects. The system works by rapidly sweeping a projector's output across a vertical range in sync with the motion of the elastic diffusers at very high frame rates, creating a solid floating image through persistence of vision while preserving depth cues such as binocular disparity and focus accommodation. Because the diffuser strips deform safely around a hand entering the volume, people can interact with the content without risk of injury or damaging the display, and image correction algorithms continuously adjust projections to maintain clarity even as the elastic surface flexes. FlexiVol supports a range of natural gestures such as pinch to scale, grab to move, and swipe to rotate, enabling direct manipulation of true 3D content without external controllers or wearables. And early user studies suggest this mode of interaction can feel more intuitive and reduce cognitive workload versus traditional indirect control devices. D1 Modular Robot is the world's first fully modular embodied intelligent robot built by direct drive tech to shift between roles the way a person swaps tools. Every section of its body is designed as an independent module that locks together with clean precision, letting users build a robot for industrial work, scientific research, classroom demonstrations, or creative entertainment setups without redesigning the entire system. The modular layout cuts downtime because worn or outdated parts can be replaced in minutes, and new capability modules can be added as tasks evolve. Verified engineering notes confirm that the system supports high-torque direct drive joints, hot-swap power modules, and standardized communication links that keep every configuration stable and responsive. D1 runs on advanced artificial intelligence control that syncs motion planning, sensing, and environmental awareness in real time. It can handle coordinated multi-limb tasks, track objects, respond to human input, and adapt to shifting conditions with strong consistency. Depth sensing arrays, inertial measurement systems, and onboard safety logic give it precise spatial awareness, allowing safe collaboration with people in labs and workspaces. Its open development framework supports custom software, third-party modules, and rapid updates, which turns the robot into a long-term platform rather than a product that ages quickly. Many demonstrations show D1 climbing, manipulating complex objects, rolling on wheeled modules, or transforming into entirely different body layouts depending on user need. Olto Infinite Machine is a futuristic electric bike from Infinite Machine engineered for both urban commuting and light off-road adventure with strong performance, thoughtful design, and practical features built into every detail. It blends weatherproof extruded aluminum and steel construction with a robust dual suspension frame that delivers a smooth ride on city streets, rough pavement, or packed gravel paths, making it far more capable than a basic cruiser. Power comes from a 750-watt rear hub motor with a peak output of 2,000 watt that adjusts intelligently based on local regulations and terrain. In standard bike lane mode, it is limited electronically to about 20 ms to stay compliant with e-bike laws. Yet, riders can unlock higher performance such as roughly 28 mph with pedal assist, or up to about 33 mph in off-road mode where legal and safe. Energy is stored in a hot swappable UL-certified 48-volt, 1.2 kWh lithium-ion battery that slides out from under the seat with one hand. Typical range per charge reaches around 40 miles, depending on speed, rider weight, and conditions, giving strong everyday usability without constant recharging, while a fast charger brings it to 50% in about 1 hour and full capacity in roughly 3 to 5.5 hours. With a starting price around $3,495, Olto Infinite Machine pushes the boundaries of what an electric bike can be by mixing powerful performance, real-world range, ride comfort, and smart urban features into a highly capable mobility vehicle. Tiny Volumetric Lamp is a compact 3D light projector and visual centerpiece that uses precision-engineered optical components to create the illusion of floating, three-dimensional patterns of color and motion in space. Built from crystal-clear acrylic, high-intensity LEDs, and advanced light diffusion systems, this futuristic lamp turns ordinary light into dynamic volumetric effects that seem to hover in mid-air, transforming any room into an immersive visual environment. At its core, the lamp's optically clear acrylic layers act as a light guide, bending and diffusing concentrated LED output, so patterns appear to have depth and dimensional form, not just surface illumination. A technique seen in other volumetric and holographic lighting concepts that blend art and optical engineering. The result is a glowing effect with noticeable visual depth and motion, captivating from all viewing angles and enhancing ambience with a blend of art and light. Despite its small footprint and minimalist form, the tiny volumetric lamp delivers a remarkably rich, futuristic glow that elevates creative installations, tech art projects, or ambient lighting setups. The advanced engineering behind the acrylic and LED integration demonstrates how miniature optical design can produce experiences that feel alive, bridging the gap between static lighting and interactive visual display. Sweetmyo redefine wearable fitness by combining advanced neuromuscular electrical stimulation technology with intelligent control to bring deep muscle activation and personalized training into everyday life. It uses clinically informed NMES science that engages muscle fibers with smooth, high-frequency signals designed to feel natural and avoid the harsh jolts typical of older electrical stimulation gear, delivering effective muscle engagement in short sessions you can do at home. The system works by sending controlled electrical impulses through a full-body wearable suit that targets key muscle groups, helping support strength building, recovery, posture improvement, and muscle tone without traditional gym workouts. Sessions can be as brief as 20 minutes, turning passive moments into productive training and recovery time with modes for strength, balance, muscle activation, and relaxation. Sweetmyo's technology delivers deep muscle contraction by operating at a higher stimulation frequency than many legacy devices, promoting engagement of deeper muscle layers while keeping surface sensation comfortable. It adapts to your selected mode and intensity in real time through an intelligent control system, helping maintain stable, consistent stimulation across different uses. OLLOBOT is a next-generation AI-enhanced robotic companion designed to bring personality, intuition, and playful interaction into everyday life. Built around observation, learning, logic, and operation, the inspiration for its name, this robot senses its environment, interprets emotional cues, and responds with context-aware actions that feel natural rather than scripted. Breaking from traditional humanoid or animal-inspired designs, OLLOBOT sports a friendly, rounded form with expressive high-definition digital eyes and soft, tactile surfaces that invite touch and engagement. Its mobile base allows it to move around the home, staying close to users while gathering data from voice, motion, and mood to learn routines and personal preferences over time. Key features include advanced visual recognition capable of detecting faces and emotional states, a high-capacity memory core that stores experiences to build a digital memory, and clearly visible controls for quick emergency stop or mute. Its animated facial expressions convey emotion and intent, creating a playful yet intuitive interface that's easy to connect with. VaporCLE is AeroVironment's next-generation all-electric helicopter drone engineered for long endurance, heavy lift capability, and precision mission performance across intelligence, surveillance, reconnaissance, electronic warfare, strike, and logistics roles. It sets a new benchmark in Group 2 unmanned aircraft systems with a rugged, compact design that teams can deploy almost anywhere with toolless setup and rapid pack-out readiness. VaporCLE delivers up to 2 hours of continuous flight time on station, roughly double the endurance of comparable quad-rotor systems, giving operators extended persistence for complex missions without frequent landings. It supports usable payloads up to 24 pounds, so advanced optical sensors, communications relays, or mission-specific effectors can be carried with confidence. And the overall gross weight range spans about 32 to 68 pounds, depending on configuration. Built with a modular open system architecture, it supports integration with more than 24 payload types, including high-resolution electro-optical and infrared imaging, signals equipment, communications gear, and precision-guided payloads. Onboard autonomy is bolstered by an integrated high-performance computer running AI-based processing for automatic target recognition and smart flight control, helping the aircraft navigate, track, and execute tasks with minimal operator load. VaporCLE's combination of persistent flight, adaptable payload flexibility, onboard intelligence, and durable field design makes it a versatile tool for modern unmanned operations that demand endurance and precision from a compact helicopter drone. MOSA enhances FLRAA. The US Army's Future Long-Range Assault Aircraft program is a next-generation effort to replace aging utility helicopters with a high-speed, long-range assault aircraft built around a modular open systems approach, known as MOSA, that lets new technologies and mission systems be integrated quickly throughout the aircraft's lifecycle. MOSA in FLRAA creates an open architecture digital backbone and modular framework that reduces upgrade costs, improves interoperability, and makes it easier to insert future sensors, avionics, and software without redesigning the entire aircraft. That flexible approach supports rapid insertion of advanced capability and keeps the aircraft relevant against evolving threats. The FLRAA itself is centered on the Bell V280 Valor tiltrotor, officially designated MV-75, which blends vertical takeoff and landing like a helicopter with cruise speed and range more typical of fixed-wing aircraft. It is engineered to fly roughly twice as fast and twice as far as the helicopters it will replace, giving Army units a decisive edge in contested environments and enabling rapid troop insertion, medical evacuation, resupply, and other assault missions across extended distances. Under MOSA, the aircraft's digital backbone supports open standards for avionics, mission systems, and communications, enabling real-time data sharing, predictive maintenance systems, and plug-and-play technology upgrades without heavy redesign or recertification work. This makes FLRAA a digital-first platform that can evolve as battlefield needs change. Hyperloop Express Freight is a revolutionary cargo transport system that uses near-vacuum tubes and levitating capsules running on magnetic levitation and linear electric propulsion to move goods at unprecedented speeds while cutting emissions and energy costs compared with traditional air and truck freight. The design targets freight transport at speeds up to about 760 miles per hour, rivaling fast air cargo but with far lower operational emissions and energy use. The system's freight capsules are engineered to fit standard air cargo containers by lowering the floor and adding internal structural openings that maximize usable volume, so several unit load devices can be carried per trip. It incorporates staggered doors on both sides and a Collins rollable loading and unloading system that enables simultaneous freight boarding and exit, slashing terminal turnaround times and boosting throughput. Express Freight is built to integrate with existing infrastructure through the same dock-lock interface used in HyperloopTT's passenger capsules, letting terminals and logistics hubs connect quickly with minimal redesign. The configurable cargo layout means operators can tailor each train's internal setup to different freight types or customer requirements, adding flexibility to a transport method already optimized for automated rapid flow. Every once in a while, humanity hits a turning point, a moment when the ideas we used to call science fiction suddenly step into the real world and demand our attention. Right now, we are standing at the edge of a shift that will redefine how we move, work, communicate, and survive. Today's breakthroughs are not just upgrades, they are world-changing inventions that will reshape everything we thought we knew about the future. If you are ready to see the tech that is rewriting the rules of what is possible, then settle in, because what comes next is nothing short of mind-bending. Let's get started.